I'm Hugh Patterson, mechanical engineer here at All Power Labs. For the past few months, we've been developing a combined heat and power system as an addition to our power cube and power pallet. The combined heat and power system harnesses the heat created by the engine in the engine coolant water, as well as the engine exhaust. This CHP system produces approximately double the amount of energy in heat to the water as it does in electrical output. So if you're running the power cube and you're generating 10 kilowatts of electricity, you'll produce approximately 20 kilowatts of heating power to the working loop. The combined heat and power system, or CHP for short, mounts on the back of our power cube. The CHP system takes water in at 60 degrees Celsius and delivers it out at 80 degrees Celsius. And it heats that water up 20 degrees in two stages. First, through a plate heat exchanger that's taking heat from the engine coolant water and exchanging it with the CHP system to raise the water temperature up about 10 degrees. Comes out of the heat exchanger, and then we've got it going through a flow switch. This is where we detect flow in the system to make sure that the combined heat and power working loop of fluid is running. From there, we go up into a shell and tube heat exchanger. In this heat exchanger, the water is on the outside, and through the middle, the exhaust gas passes, and then exhaust gas comes out the heat exchanger and out of the exhaust stack. Our monitoring system here is our first alpha unit. Just an Arduino monitor, our Arduino board with 5 thermocouples. We're measuring the water temperature into the plate heat exchanger. We measure the water right before it goes into the shell and tube heat exchanger, and then we measure the water temperature coming out of the shell and tube heat exchanger. And we're also measuring the exhaust gas temperature and the engine coolant water temperature. And we're using, with those numbers, we can characterize how much heat, how much energy we're capturing from the engine coolant water as well as the exhaust gas. And also here we've got a high pressure relief valve as a safety valve in the system in case high pressure is produced by boiling water. If we have high return temperatures to the CHP system, because there's not enough heat being dumped where the hot water is being used, say in a warehouse or in a crop drying or something, then we have a exhaust gas bypass valve. So we bypass the shell and tube heat exchanger and send the exhaust gas straight out. And this allows us to safely operate the system with high return temperatures in the working loop, or if the customers want to use the power cube without the combined heat and power system, then we use this bypass valve to direct the exhaust gas past the heat exchanger rather than through it.